Welcome to Live on Plato's Cave. I am Mario Veen. This is episode 20, Being Better Earthlings, with Marcia Bjornerud. In a way, Plato's allegory is a story of failure. Failure to integrate new insight about our reality. The person who has been to the surface returns into the cave and tries to show them what he has seen. He tries to get them to move, but they remain stuck in their ways. We might laugh at those prisoners, but as Plato says, they are just like us. For example, we have known for a while that we're changing our planet, and that if we don't act now, it will threaten our survival. We also know exactly what we need to do, and yet we are not doing it. So, how will this end? In her new book, Geopedia, Marcia Bjornerud writes, there are two ways for the Anthropocene to draw to a close. Either we learn to be better Earthlings, blending into the background and no longer distorting biogeochemical cycles, or we go extinct. So yeah, we are exactly like those prisoners, at least on a collective level. We keep watching the shadows of economic growth, of maintaining our habits and our comforts, instead of focusing on what is actually happening. But we could ask ourselves, what would actual growth look like? That's the question I address in this podcast. Socrates said that the purpose of philosophy is to know thyself. But who am I if not an Earthling, an inhabitant of planet Earth? What does it mean to know yourself as an Earthling among Earthlings? There has perhaps never been a more urgent time to answer this question. Fortunately, we are living in the golden age of the Geosciences, which can help us understand Earth and being an Earthling. I spoke about this with Marcia Bjornerud in episode 5, and I'm happy that she agreed to speak with me for a second time. Marcia is Professor of Geology and Environmental Studies at Lawrence University in Appleton. Her research focuses on the physics of earthquakes and mountain building, and she combines field-based studies of bedrock geology with quantitative models of rock mechanics. Marcia is a contributing writer to the New Yorker's science and technology blog Elements, and the author of books that help us better understand our planet. Reading the Rocks, the Autobiography of the Earth, and Timefulness, How Thinking Like a Geologist Can Help Save the World. And the book that just came out is called Geopedia, a Cabinet of Geologic Curiosities. Thank you so much for speaking to me again. We spoke for a little over a year ago about timefulness and geology. I just listened to the episode yesterday, and there we did mention Geopedia already. I think it wasn't out yet.
No, it just came out about a month ago.
I have it here. I read it during my holiday. I really appreciate how you did this book. So it's a small book. It's good to take on holiday for people who are going on a summer holiday. And it's just to very simply, it's an alphabetized list of concepts, selected concepts that you find important, I think, for geology. How did you make that selection anyway? Because if I have a list of concepts that I find important in my area, but they wouldn't fit in a book, and I'm sure it's the same for you too.
Yeah, it was an interesting project. It's part of a larger series that Princeton Press has released, these pedias, small natural history books. So the idea was not mine, but I was given fairly free creative rein to decide how to structure the book, other than it had to be an alphabetized list. And so frankly, I chose words that were interesting words that had a wide range of origins, but also that collectively spanned a wide space of the geosciences, so that I hope that if one reads most of the entries, you come away with a kind of impressionistic understanding of the geosciences, how we know anything about the way the Earth works, and maybe also just an appreciation of the sheer profligate variability of things on Earth.
Yeah.
So it's a bit of a confection of a book. It's a chocolate box book. You could open it and take a bite and close it again and then come back to a different point. But I hope it has enough substance to feel like a satisfying intellectual, something to delve into a little bit. So it's not a magnum opus, but I hope it entertains and educates a little bit.
Yeah, and I think it contributes to geological literacy. I don't know if we discussed this in our previous episode, but I mean, I'm very interested in getting to know different areas of science because I have I had my geology was in high school. That's about it. And now because of what's going on the planet and climate change, that's how I become interested in geology. But I don't have this whole education. And after you've read maybe one or two kind of overview books about geology, well, that's important too, of course. You get more an impression of the whole picture. But then I'm hungry for more. But then usually you have only like either more of those books that are kind of, you hear kind of the same things that come back, or you are in the really specialized geology literature. What I appreciate about this book is this approach to concepts. And that's something I do in my own work as well with philosophy, rather than speaking about the philosophy of Kant, or we're going to talk about empiricism. Just to take one concept, in this case, it might be experience and the relationship between experience and something else. And so I think that really works well.
And I mean, you're not alone in perhaps having this yearning to understand the planet better, but not ever having had the opportunity. And I mean, really, to me, it's a colossal tragedy that in the West, our very sophisticated educational systems essentially do not include teaching people about the planet. And it's sheerly an artifact of the maturation of the different sciences and when curricula became sort of codified. I mean, I'm more familiar with how that happened in this country, but I think in Europe it's the same thing, that at the time, perhaps in the early 20th century, when secondary school curricula were being established, the geosciences were still a fairly primitive discipline. Physics and chemistry and then biology were coming into their strengths, and it's just almost beyond comprehension that most Earthlings really do not understand the place they live, to the great detriment of us all. And this includes people who wield tremendous amounts of power, who are making decisions that have planetary implications, but are doing these things in complete ignorance of the effect they will have on the planet. I just wish we could rewind the tape and go back and have rigorous earth science threaded throughout everyone's education. We would be better off, not only for environmental reasons, but I think spiritual reasons as well, understanding really in a fundamental way who we are as Earthlings.
Yeah, I like that term, Earthlings. You use it a lot, and
I do, and it's just true.
Yeah, we are. Yeah, that's pretty much it. We're Earthlings, but they're also. Who else would you consider Earthlings?
Exactly. I know it doesn't only mean humans. It means all of those who dwell on Earth, and maybe even inanimate components of the Earth.
I think if we compare it with something else, which is taught more, I guess in high school, it's about outer space. But you write that we know more about outer space than about the world under our feet.
Well, we know more, for example, about the surface of Mars than we do of Earth, which is, because we have these oceans, and I love the oceans. It's a good thing. But it is kind of amazing that we have higher resolution topographic maps of Mars at this point. And of course, we should explore space. But I do always rankle when people think that's the only way to get children interested in science. There's plenty of remarkable, mysterious stuff going on right here under our feet that we don't understand, and we need all kinds of brains to start investigating. And space is not the only way to pull people in.
This is such a parallel with philosophy. We discussed, I think it's episode 10. We discussed, somebody who started out doing biology, but then got interested in philosophy and particularly Heidegger. And this is one of the points that Heidegger made. It's like it's easier to look at the star than look at yourself. And of course, he means that in kind of a different sense, in like what does it mean to be human? But at the same time, and this is actually what Heidegger was criticized for, is that to be human also means to be born and to grow up, and basically to be an earthling as well.
Why was he criticized for that? It seems.
One part of the understanding is that we just kind of show up on this earth. We inherit this whole time that we didn't choose, but it's ours. And how do we deal with that? But the part that he didn't address is that we also are the product of an evolution. And that there's a development, for instance, from child to adult. But also another philosopher, Bernard Stiegler, took that up, and he started paying attention to how we started using flints and how this became kind of a relationship with the earth that we had that we now call technology. Only in the beginning, it happened very slowly. So our own evolution could be in sync with the technical evolution. But the problem now is the technical evolution is going so quickly that our biology and our society cannot adapt. So I just had to think about this part of this understanding of who we are. I mean, this is one point that Heidegger really emphasizes, is that we are from the earth. Like, I think he even draws a parallel between human and an old word for earth or something. Yes. So, I mean, I guess he would say we are earthlings as well. We're skipping a bit around, but I guess maybe that fits the book as well, because you can skip around in it. Because we're speaking about Earth now. You just said we know more about the surface of Mars than the surface of the Earth, and you don't. That's not the hyperbole. You mean this literally?
I do. Yeah.
That's. I mean, I just have to let that sink in a little bit.
Just the topography. Of course, we don't have as much information about all of the rocks on Mars. But in terms of a map of the surface, yes.
So people are speaking about terraforming another planet. You have something to say about terraforming. I think that was another concept, pedogenesis.
Well, yeah, that is how soils form.
So my question would be, do you think it is realistic to expect that we can terraform another planet?
The short answer, no.
And why not?
The very suggestion indicates a profound ignorance of the deep evolutionary history of the planet and life on this planet, and how great expanses of time are needed for all of the entities that create a livable planet have come to be, and also denies the fact that we evolved on this planet as parts of this particular constellation of biogeochemical circumstances. And to think that we could just, by fiat, recreate that in a matter of even a few centuries is just so hubristic, I can't even express it. It just shows a profound ignorance of all of natural history. And soil, I think I bring up the idea in the soil entry on pedogenesis. Soil is a greatly underappreciated amenity on Earth. It is a quasi-living entity that is partly broken down rocks, partly organic matter. It's a living community of things, many of which we have not even begun to characterize. We don't really know what the microbiome of soils in any given place are. And to think that we could just engineer these things when we don't even understand them here on this familiar place is, I cannot believe that some of these ideas have gained traction with the public and again are propounded by very powerful and very rich people.
Yeah.
So it just underscores this idea of geo illiteracy or planetary illiteracy that I was talking about. And in this case, it's dangerous because it has to do with decisions that are being made at very high levels.
Yeah.
Yeah.
Did the Earth always have soil?
Well, that's a really great question. If by soil you just mean broken up rock, I suppose early on. So the moon, for example, we say there's soil on the moon, but it's just broken up pulverized rock from meteorite impact. But that is not a soil that could grow much.
There are no fungi and everything in there. No, there's no life in there.
It's really sterile. Yeah. And probably actually modern soils as we know them on Earth today did not emerge until as recently as maybe 450 million years ago, which is just the last ninth of Earth's history, because until then there were no land plants. Plants are a relatively recent thing on land. And that's a crucial part of breaking up rocks, the acids that plants exude and the physical action of roots, and then the animals that also came onto land after plants colonized the land are really what creates soil as we know it today, this complex ecosystem.
And how long did that take?
I mean, there are so-called paleosols in the geologic record, ancient soils that have been petrified that are as old as about 450 million years. But those are the oldest ones that are really, we can see, like the A horizon and the B horizon and look like soils today. So it's a relatively recent invention on Earth, if you look at the great expanse of geologic time. And it's apparently unique to Earth because soil is it's not just mineral matter, it's living matter as well. And so we don't see it on any other planet that we know of. And it's pretty crucial to our survival.
So if I understand it, first the life, let's say the biosphere was only in the oceans.
Right. Mm-hmm.
So 450 years ago, it came on land. First plants like mushrooms, I think.
Well, yeah, fungi are a different kingdom altogether.
I'm reading this amazing book about fungi. I can't find it, but you probably know it by Sheldrake.
Sheldrake, I love that book, Entangled Life. He's a brilliant writer too. Yeah. So fungi and plants probably came on to land at about the same time.
Yeah.
It's possible there were some early algal colonies that were making crusts on land before that, but green plants did not come onto land until about 450 million years ago in the Ordovician.
Okay, and those started to break up the rocks, grow their roots, plants dying, that became part of that. And so that kind of that mixture early on of different rocks and pulverized rocks and biological matter, I guess, together, that was kind of the early soil. Or was there another ingredient as well?
Yeah, no, that's the main thing, that rocks physically and chemically broken down, and then organic matter mixing into that, and then invertebrates, worms and insects that live in the soil, further modifying it. And again, we don't even know the census of bacteria and fungi and vertebrates that live even in a small amount of soil in a given place. Yeah. And actually in the geologic record, we can see this change, the colonization, I sort of hate that word, but the occupation of the land by land plants profoundly changed erosion rates. There's a real change in river systems. Rivers became more likely to be channelized rather than running rampant over the landscape. So this was really a major change, kind of late in Earth's history.
In another episode, so the biologist said that the Earth's geosphere is a biosphere. So I start to understand that a little bit more. So one other thing, I was really surprised. Because what I remember about geology is plate tectonics and Pangea and volcanoes. From even my primary school, I was really interested in dinosaurs, and I saw this picture of this is what the Earth looked like when they lived, and I mean it was very amazing to me. But because for me that's something I learned in primary school, so I assume we've known this for hundreds of years already, at least. And I was really surprised to read in your book that plate tectonics, that it has only been really acknowledged in geoscience since the 1960s. That's only half a century ago.
That's right. Yeah.
Did you get it in your own education, your own high school, or?
Not really, no.
No.
And I was in university at a time when probably 2/3 of the faculty were people who had been appointed prior to the plate tectonic revolution. So, I mean, they were teaching tectonics, and I don't think there was anyone who didn't embrace the idea, but they were trained in a pre-plate tectonic paradigm. So yeah, it's really extraordinary that in there was almost a period of about a year where the geological community went from being what we now call fixists, thinking that the continents were stuck in place, to being mobilists. 1965 was really the inflection point where new data that had been classified by the US Navy essentially became available about the seafloor and magnetic patterns in rocks on the seafloor that were really the key to understanding seafloor spreading, which is really the key to understanding plate tectonics. And in about a year, when the mechanism by which continents could be moved was finally recognized, there was just this complete change in the view. I mean, there had been people even back in the early 20th century who proposed that continents drifted, but could not explain how this could happen. And so the key was the mechanism of seafloor spreading, that once people saw, oh, it's this great conveyor belt, this volcanic seam that runs around the world that sort of pushes the continents apart, then all at once, this was this gigantic paradigm shift.
Suddenly you're living on a moving planet.
Yeah. And that is really a first order change in intellectual framework for the field. It reunified fields that had become just sort of separate kind of entrenched disciplines. Paleontology sort of suddenly made sense. How could you find, for example, dinosaurs that could not swim across great oceans on vastly different continents? So lots of things suddenly made sense.
Yeah. But that's quite a fundamental discovery in a science that is quite old. So then I'm wondering, what is the next one? Let's first ask, have there been any major discoveries like that since?
Oh, yes. Oh, yeah? I mean, I think the plate tectonics revolution, it changed the geosciences into modern science. And it coincided with a lot of technological advances, especially ocean drilling. The capacity to drill long cores of rock into the oceans was another part of the discovery of plate tectonics. And this then opened up high resolution records of climate change over the past. Other things that have happened, even since I've been in the discipline since about 1980, have been huge advances in isotopic dating of rocks. So we really have high precision methods of knowing how old rocks are, including the oldest rocks that we can find on Earth. So we have much, much better calibrated geologic timescale, even going back to the very distant early days of the planet. The whole field of biogeochemistry, which is wrapped up with climate, is really new. This just did not exist when I was an undergraduate student at university. This was not a distinct field. And now we recognize that one of the most kind of important characteristics of the Earth are these biogeochemical cycles of carbon and sulfur and nitrogen and phosphorus and, of course, water, that are all tangled up with each other in complex ways over different timescales. That was not a way that people were thinking about the Earth. And again, that's knit back together fields that had evolved apart. So, it's brought igneous petrologists who study volcanoes in conversation with people who study climate, who study soils. So the discipline has become, I think it's moved away from its traditional emphasis on taxonomy and classification to systems thinking. So it's a completely different discipline, even since I studied at university, and I'm not all that old. I've been in the field for 35 years, but we are, I would argue, in kind of a golden age in the geosciences, and that is not something that the general public is aware of, I think.
No, not at all, I think.
Yeah.
And especially in this context where it's very crucial that we get to know the planet that we live on.
I mean, and another thing that's closer to my own field is much better understanding of earthquakes and seismology. And that's also got huge humanitarian importance. So we can't prevent earthquakes, but we have much better records and understanding of the physics of what happens in earthquakes. And it's really tragic, as I said before, that we aren't able to better communicate some of this knowledge to people who live on this very dynamic planet.
So what is, how, because we have people are interested in science, I think, in general. And one of the ways people access science is through the internet. So I've Googled a little bit about the greatest scientific discoveries, and you find, well, gravity, Newton, the Copernican system, DNA, theory of relativity, the periodic table, the sequencing of the human genome, which are all really important things. But which discovery from geology would you include in there?
Well, certainly just mapping deep time, the awareness of the immense antiquity of the Earth, and actually being able to tell the story of the planet in some detail over the last 4+ billion years. To me, that is one of the great intellectual achievements of humanity, and it's frustrating that it's not on lists like that.
And why? But why? Why? What is it? Yeah, I don't want to.
Yeah, I think there's so many reasons, and I think some of it can be possibly, you're the philosopher, you can tell me if this makes sense, but I think some of it can be traced back to the ancient Greeks, where there were the nested spheres. The mundane was the corrupt sphere that was not perfect. The heavens were perfect, and so there's just always this kind of disdain for the mundane. And of course, mundane literally means of the world, of the earth, that we just assume that this place is not interesting or important.
Yeah.
And then, as I said before, geology is a late blooming science. It lagged far behind physics for sure. And so for complex reasons, that reputation has clung to it. And it's now, this really flourishing, intellectually dynamic field, but it just doesn't rank. People don't think of it as science. There is an implicit hierarchy of the sciences, and geology ranks pretty low in most people's minds, unfortunately.
I spoke to a theoretical physicist before, Vincent Icke, and he says the greatest question in physics is basically how to have a unified model where gravity and quantum mechanics, because there are two theories, they explain so much, but they don't go very well together. So is there what would you say is now the greatest question in geoscience, the unknown question that everyone is working on, and that they think, wow, if we would only somebody could come up with this, then we would have a major breakthrough again in the geosciences?
I don't know if there's anything analogous to that, but there's just this sense that at last we have the analytical and computational tools to really delve into some of these complex systems that we're just beginning to kind of recognize.
Yeah, so does that mean discovering that there is so much to know, so much that we don't know?
Yeah, and a lot of it we've needed better computational capacity. These things are immensely complicated. The climate system, just, statistical analysis and modeling. You just need computer capabilities that can crunch through lots of numbers. Even knowing what questions to ask of, say, soils, and we have DNA sequencing, all kinds of new tools at hand that are allowing us to delve deeper into these complex systems. So I don't know that there's a question. It's more just still in this data gathering mode, trying to characterize systems, understand how they evolve over time, how stable they are. I suppose for humanity, a really pressing question that scientists of all kinds are addressing is how stable or fragile is the Earth system? Are we really pushing it to some kind of threshold state that's unprecedented geologically? Certainly we are. I can say definitively we are pressing the planet to a state that's unprecedented in human history. But how does it rank really with some of the great mass extinctions of the past?
In the last conversation, we also discussed this idea of uniformitarianism. So yeah, very simply that maybe it's better if you explain it.
It's the simple idea that the present is the key to the past.
Yeah.
So we can't visit the past, but we can reasonably assume that the same physics and chemistry laws applied and basically the same geologic processes applied to the past as the present. So that's the lens through which we look at rocks and interpret them. Mm-hmm. But as the Anthropocene marches on and the rates of geologic processes are greatly accelerated by humans, in some ways, uniformitarianism doesn't apply anymore because we're doing things to the Earth that wouldn't have happened in the geologic past. And that's kind of terrifying because that's our main tool for.
Yeah, because that was my question. Does it also work the other way around, that you can look in the past and you can look at, well, let's find a situation where, where the circumstances were similar to the ones that are happening on Earth now?
Yes, and in fact, more and more papers in the geological literature are doing that. It's really kind of interesting that
what do they come
looking
up with?
at an ancient analog for potentially future events.
Yeah.
Yeah.
And what is their takeaway?
Well, there's some fairly terrifying scenarios. One example is this event that happened about 55 million years ago. It has this unwieldy name, the Paleocene-Eocene thermal maximum. And so it's post-dinosaur extinction. It's a time when the Earth was already fairly warm. Mammals were kind of beginning to diversify. And then there was some huge release of methane, probably from a form of icy hydrocarbons called gas hydrates or clathrates that belched huge amounts of methane into the atmosphere, possibly in a matter of a few weeks, that would be comparable probably to 3 times what humans have put into the atmosphere so far from fossil fuel burning. So a really large sudden release of methane, which is a very potent greenhouse gas. What we see basically is severe ocean acidification, a mass extinction. It's not one of the big 5, but a pretty profound mass extinction in phytoplankton in the oceans, which are at the base of the food chain, that then rippled up and had bad effects on higher marine organisms. Also, just complete rearrangement of ecosystems on land, and a period of real climate instability for probably 100,000 years or so.
And what is instability? What range do we have to think of? Because
the temperatures, global average temperatures rose, geologically suddenly by about 10 degrees Celsius, and that's tremendous.
Okay, because people are speaking now around we have to limit to 1.5 degrees since the Industrial Revolution. So that's 200 years, 1.5 degrees in 200 years.
Yeah, something like that. Yeah.
Okay.
Yeah, and we're probably way past 1.5 now.
Yeah.
So this is an interesting, sobering event. It didn't cause one of the big 5 mass extinctions, but it was a pretty severe mass extinction, especially in the oceans. And it took a long time for all of that carbon to be kind of digested again by the biogeochemical cycles and things to return to a relative state of stability. Certainly 100,000 years is long for humans. And the challenge, of course, is we just don't quite know how quickly some of these things elapsed. Was it really a couple of weeks of release? Over what period of time did this really happen? The resolution of the geologic record is not high enough for us to distinguish between, say, weeks or decades.
Yeah. But then it sounds like, so geology often has the idea we're studying, of course, we're studying the rocks now, but we're trying to understand the past and the past of the planet. And when you speak about deep time, someone could say, well, the same thing people say about history, like, okay, but it already happened. So, I mean, good if you find it interesting, but it's finished already. We live now.
But we live in the shadow of these things too. I mean, they influence us. And they may be analogs or cautionary tales about the future.
Yeah. And at the same time, it sounds like you're trying to understand the current situation, and that in a way there is no precedent, which may this is just my understanding at the moment, and please correct me, because in geology you make a distinction between the geosphere, the atmosphere, the hydrosphere, the biosphere. Am I missing any? There are probably many. Or so, for instance, I don't know, Mars has a geosphere but no biosphere, as far as we know. And maybe in the past it had, but we don't know.
Probably not. And very little atmosphere either, very thin. And that's really one of the characteristic things about the Earth, is the way that all of these spheres are complexly entangled with each other. They're not just these discrete entities. There are these exchanges of mass and energy that go on all the time. And that is really the distinguishing character of Earth, I would say.
But then if we say, well, humans are causing climate change, it's not really humans as, like, a biological person, but what people are calling the technosphere. So the whole infrastructure and what we're taking out the fossil fuels and burning them, which kind of disrupts the balance between taking in carbon and carbon emissions that has been happening.
And our folly is thinking that the technosphere is separate. We have this illusion that this is us, and this is
So that's the old idea that there was, like, do you know Bruno Latour?
Yeah. Mm-hmm.
Yeah, he wrote this book, Facing Gaia, where he says it's like it's a new ontological regime that we have to get used to in the context of climate change, namely that we've been living, even the term the environment. It's like the environment used to be, when I was small, that's what you called nature. And the environment is just like, you have the environment and humans are placed into it. And he says, he has this metaphor where he says it's like, so the human drama has been playing out on a stage, and the environment, the world, the planet has been this stage, the background to our human drama. And then he says, but now it's like the decor has gotten on stage and become one of the actors. And it sounds very much, if I think about geoscience, where you include plate tectonics, where you include, your field where you view rocks as fluids, where you see mountains as ephemeral, which are moving, rising up and disappearing again. It sounds very much like that is already the understanding that is there in the geosciences, that there's no solid state, it's all moving.
It's all animate, and we're part of it. And it's just a delusion that we are separate. We never were, we never will be. And as I've said before, with the Anthropocene, some people have this idea, well, this is now the time where, we're defining the Earth. No, I mean, in a way, what we've done is unleashed, we've created disequilibrium situations that are going to cause the power of the Earth to come back with a vengeance upon us. It's not that we are in charge or have changed the rules. The rules are still going to be the same as they've always been. The Earth has always been in charge. We have had the illusion that we are, and now we're going to be reminded that the Earth is very powerful, and when it's pushed out of equilibrium, it will try to reestablish equilibrium.
You were saying that the technosphere is not separate?
we like to think it is, but is entirely dependent. There was a U.S. Senator from Wisconsin, where I am, who was actually the person who came up with Earth Day. His name was Gaylord Nelson.
Yeah.
Back in the 60s and 70s, he was one of the early voices of environmental conservation. And he would say that the economy is a wholly owned subsidiary of nature, which is, kind of an obvious statement, but for the capitalists who like to think that capitalism is the real world and, nature is outside and we can ignore it, except that we want to extract fuels and things. That's, a sobering reminder. And it's just folly that we think we can opt out of nature.
As we talked about before, it's easier to look at the stars than look inside the Earth, right? We're trying to understand the geological age that we live in, but we live in it. So we're kind of formed by it. Our thoughts are formed by it. And our technology is shaping so much our self-understanding and changing our self-understanding. So I wonder, is there a way to look at the technosphere from the perspective of geoscience that makes it more scientific, more objective? You can look at the geosphere more objectively maybe than at the technosphere, because the technosphere is very unknown, but it has a major impact on the geobiochemical cycles on the Earth, right, at the moment. So it is something that is influencing the subject of geoscience. So my question is, where do you place that as a geologist? Is that just one of the spheres, or?
Oh, I see. Well, It's Johnny come lately, as we say, something that's just arrived on the scene and has not previously been part of the Earth story.
Yeah. But it's also fine to say, well, this is the limits of our science and we're not saying anything about it. So I'm trying to understand, is geoscience studying the technosphere? I guess that's the most simple way I can ask it. Or is it saying, well, this is something for, I don't know, anthropologists?
Well, okay. I guess I'm all right. There is a new sub group of geoscientists who are certainly, focusing on the human impact on the environment, if that's what you mean. So yes, we are beginning to consider the technosphere. If by the technosphere you just mean all human industrial activity.
Yes.
Yes. So
living in cities, building buildings, drilling into the earth, flying airplanes, the whole thing, internet.
Yeah. So we are turning toward that. And it's interesting. There was, I think, this idea that that's not really geology for a long time. And I think sometime in the early 90s, geologists started realizing, well, this is affecting geologic phenomena and is a urgently needed area of study. So yes, this has become a new area of focus in the geosciences. I had a thought, I guess, as you were talking about, it's easier to look at the stars than at ourselves. I think that's really where I think we are as a educated 21st century society. In some ways, what we really need is wisdom and not knowledge at this point. We have lots of scientific knowledge. We have technology that has certainly improved at least some people's lives tremendously. But what we lack is the introspective understanding of really our own needs, how to live peaceably together. And I was thinking about this with the metaphor of the cave. It's not that we haven't emerged and seen the light. It's just we don't know how to process that, and we've been sort of so overwhelmed with so much new information, new technology, that now we need to maybe go back to the cave and contemplate what it all means.
When he comes back, he's like made fun of, right? Because his eyes are not used to the dark, and they
Right.
say, well, what, you ruined your eyesight, and so it's not integrated.
Yeah. But we collectively maybe need to slow down, get used to the dark a little bit again, and somehow catch up spiritually and socially, and not just keep hurtling on to the next thing. I mean, I'm a scientist and I want light, more light. but wisdom, we need to cultivate that at the same time. And a large part of our problems here in the Anthropocene are because we have not. We've just believed that technology is the savior, and we don't need to contemplate the human implications of the next discovery.
Yeah, you have kind of a sobering message. And one of the things I love about your book is that, one entry is amethyst, and you write very, passionately about that. And then another one is Anthropocene. And they're on completely different levels and dimensions, but they're both concepts that we need to understand, things like amethyst in order to grasp that other concept. So you say, well, there's basically two options because, one thing we know about geological ages is that there's always a next one. So there will be another one after the Anthropocene. And you say either we learn to be better Earthlings, blending into the background and no longer distorting geochemical cycles, or we go extinct. So I prefer the first option. One insight that gave me is that we, the discourse around climate change is a lot about what can we do? People need to do more. People need to do more. Which in a way, I understand, but you say actually blending into the background. That's another way of thinking. And it made me think of an article I read about a study about reforestation. I'm guessing that field is about, what can you do to reforest, and you have this other word, rewilding and everything. But it sounds like we are going to reforest something. But that article said, well, the best way to do that is leave it alone. Don't do anything. Don't go there. Just leave it alone, and that's the best way. So can you talk a little bit about what does it mean to blend into the background? Like, what does it mean on a conceptual level, but also do you have any ideas about what could we do or not do rather to achieve that?
I have lots of ideas, and I have had many contentious conversations with colleagues who are in economics who always say that I'm impossibly naive. But I mean, what I mean by blending into the background is acknowledging our status as members of the biogeochemical cycling community, really understanding that we need to get with the program. And I think a big part of blending in would be reducing the world's population slowly over time, not thinking that it's okay to just have, 10 billion, 12 billion, 15 billion people, but, making a priority to slowly reduce the population. And that can happen by educating women and girls, and that's been shown to be a very effective way. And then this is what my economist colleagues always say is just an impossible thing, that just not having growth be the metric of a healthy economy, that at some point, not just growing, we need to slowly downsize. And that means consuming less. And certainly, the US is the worst of all countries in the world for per capita consumption of pretty much everything. There's just, and this is a hugely unpopular thing to say, even among, left-leaning people, that they want to bring people on board with the green energy revolution, that, you can just keep living your same lifestyle without having to actually cut back. Well, actually, we're going to have to cut back. We can't live this way. This is not natural. And then we don't really need to live this way. So degrowth, shrinking our personal and collective consumption, letting nature repair itself, which it does very nicely. So that's what I mean by blending in.
Yeah.
And, not popular, especially in a country like this, where just capitalism is the credo and consumption of more is just, thought to be a patriotic duty.
Yeah, we have a concrete example now in the Netherlands. I don't know if you follow that, but the Milieudefensie and Urgenda, there are two environmental organizations. They sued the government for not adhering to the climate Paris Agreement. Yeah.
Mm-hmm.
So they have to limit it's not carbon, but it's the other one, stikstof, in nitrogen, I guess.
Okay. Mm-hmm.
And a lot of that comes from farming. So now, because the government was forced by the judge to do this, which to me is quite ironic because they were forced to take care of their... Anyway, I won't go into a tangent. But the concrete reality now is that a lot of farms have to close. And that has many people angry, understandably, because that's your business, that's your family business.
Yeah, I mean, and the problem is that they've been built up under certain assumptions and they've evolved into what they are, and to then suddenly change the rules is a problem. We need kind of dismantling these ways of...
But then other people are saying, well, again, Bruno Latour is saying, well, we have become the generation that could have prevented this. So people are rightfully angry at that, but why, to bring in your idea of timefulness, why does it need to happen this way? Because if we had acted even 5 or 10 years ago, it wouldn't have to be so dramatic. You wouldn't have to make these dramatic measures. And so I like your blending into the background, reducing population over time and things like that into the future that we can now think about. We need to start doing this now, because if we don't do it now,
catastrophic change will be needed.
I'm just going to say thank you for this conversation.
It's always just really stimulating for me to talk across disciplines and
interdisciplinary. Yeah. Thank you for listening. This is an independent educational podcast, and I fund it myself. A lot of time and money goes into making it. I could really use your support. Go to livefromplatoscave.com for ways to do that.